Welcome to the Elm Street Community Church's instructional video on setting up an AWS Internet Cafe. In this video, we will guide you through the comprehensive steps to create a secure and efficient cloud infrastructure using Amazon Web Services. This project aims to provide digital resources and training to our community members, enhancing their employability in the IT sector. Let's begin by creating the main virtual private cloud, or VPC. First, log into the AWS Management Console. Then navigate to VPC from the Services menu. Next, click on your VPCs in the left sidebar. After that, click on Create VPC. For the name tag, enter ESCC_main_VPC. For the IPv4 CIDR block, type in 10.0.0.0/16. Finally, click Create. Next, we will create the main public subnet. In the VPC dashboard, click on Subnets in the left sidebar. Then click on Create Subnet. For the name tag, enter ESCC_main_public_subnet. Select ESCC_main_VPC for the VPC. Choose US East 1A for the availability zone. For the IPv4 CIDR block, type in 10.0.1.0/24. Finally, click Create. Now let's create the main private subnet. Click on Create Subnet again. For the name tag, enter ESCC_main_private_subnet. Select ESCC_main_VPC for the VPC. Choose US East 1B for the availability zone. For the IPv4 CIDR block, type in 10.0.2.0/24. Finally, click Create. Next, we will create an Internet Gateway. In the VPC dashboard, click on Internet Gateways. Then click on Create Internet Gateway. For the name tag, enter ESCC_Internet_Gateway. After that, click Create. Now, select the newly created Internet Gateway and click on Actions, then attach to VPC. Choose ESCC_main_VPC and click Attach. Now let's create the main route table. First, click on Route Tables in the left sidebar, then click on Create Route Table. For the name tag, enter ESCC_main_route_table. And for the VPC, select ESCC_main_VPC. Finally, click Create. Next, we will create a route for internet access. Select the route table you just created. Click on the Routes tab, then click Edit Routes. Now, click Add Route. For the destination, enter 0.0.0.0/0, and for the target, select the Internet Gateway ESCC_Internet_Gateway. Lastly, click Save Routes. Now, let's associate the route table with the public subnet. With the route table still selected, click on the Subnet Associations tab. Click Edit Subnet Associations. Select ESCC_main_public_subnet and click Save. Next, we will set up a NAT gateway for the private subnet. Open the Amazon VPC console. In the navigation pane, select NAT Gateways. Click on Create NAT Gateway. Name tag ESCC_BU_NAT_Gateway. Choose a public subnet where the NAT gateway will reside. Allocate an elastic IP address for the NAT gateway. Click Create NAT Gateway. Wait for the NAT gateway to be available. Now let's create and configure the private subnet route table. In the left navigation pane, click on Route Tables. Click on Create Route Table. name tag private underscore subnet underscore root underscore table, VPC, select the VPC where your private subnet resides, click create, adding routes to the route table. Select the route table from the list, click on the routes tab, click on edit routes, click add route, destination 0.0.0.0/0. Target, select the NAT gateway you created, click save changes. Associating the route table with the private subnet. With the route table still selected, click on the Subnet Associations tab. Click Edit Subnet Associations. Select the checkbox for your private subnet. Click Save. Next, we will configure security groups. In the EC2 console, navigate to Security Groups. Select the security group associated with your instances in the private subnet. Click on the Outbound Rules tab. Ensure there is a rule that allows outbound traffic. The type should be all traffic, or you can specify HTTP or HTTPS as needed. The destination should be 0.0, 0.0/0. Finally, click Save Rules. Now let's modify the network ACLs for the private subnet. In the VPC console, select Network ACLs. Find the ACL associated with your private subnet. Click on the Inbound Rules tab and ensure that there is a rule allowing all inbound traffic from the NAT gateway. Then click on the Outbound Rules tab and ensure that there is a rule allowing all outbound traffic. Don't forget to click Save Rules. Let's test the internet access. First, launch an instance in the private subnet. Then, connect to the instance using an instance in a public subnet via SSH. Finally, test internet connectivity from the private instance by running a command like curl http://www.google.com. Now we will create a backup VPC in Ohio. Repeat steps 1 through 7 to create a new VPC in the Ohio region, which is US East 2. Name the VPC ESCC_backup_VPC with CIDR 10.1.0.0/16. Create public and private subnets with appropriate CIDR blocks, 10.1.1.0/24 for public and 10.1.2.0/24 for private. Name them ESCC_BU_public_subnet and ESCC_BU_private_subnet. Create an internet gateway and attach it to the backup VPC, named ESCC_backup_internet_gateway. Next, we will create a VPC peering connection. In the VPC dashboard, click on Peering Connections. Then click on Create VPC Peering Connection. Name tag ESCCC_VPC_peering for VPC requester. Select ESCC_main_VPC. For VPC acceptor, select ESCC_backup_VPC. Click Create. Now go to the Ohio Region VPC dashboard, select the peering connection and click Actions, then Accept Request. Now let's update the route tables for peering. For both VPCs, update the route tables to include routes for the peering connection. In ESCC_main_route_table, add a route for 10.1.0.0/16, pointing to the peering connection. In the backup VPC's route table, add a route for 10.0.0.0/16, pointing to the peering connection. Next, we will create workspaces in the private subnet. First, navigate to the Amazon Workspaces service. Click on Directories and create a new directory if you don't have one. For the directory information, use a managed Microsoft Active Directory domain. The directory type should be Microsoft AD, and the operating system version should be Windows Server 2019. Choose the standard edition for the edition. Enter the organization name as ESCC Internet Cafe. The directory DNS name should be elmstreetccc.org, and the directory NetBIOS name is optional, but you can enter Elm Street TCC. Don't forget to enter the admin password. Click Create. It can take up to 45 minutes to create the directory. Once the directory is created, select the subnets, both private and public, then click Register. When the directory is ready, navigate to Workspaces. Click on Launch Workspaces. Select your directory and choose the Windows 11 bundle. Specify the number of workspaces you want to create. For each workspace, ensure you select the private subnet, which is ESCC_main_private_subnet. Create a test user with the following details: username, testuser1, name test user, and email cow.m.moua@gmail.com. Finally, click Launch Workspaces. Now let's set up auto-triggering of Workspaces instances upon user creation. First, log into the AWS Management Console with your credentials. Navigate to Workspaces by searching for and selecting it in the AWS Management Console. Choose the directory where you want to create users and workspaces. Next, modify the workspace creation properties. You can use either the AWS CLI or the AWS Management Console. If you're using the CLI, the command will look like this. Make sure to replace with the actual ID of your directory. Go to the Active Directory section in the AWS Management Console and create new users in your Active Directory. Each new user created will trigger the creation of a workspace instance automatically. After the workspace is created, users will receive an email notification containing their login credentials. Ensure that the email settings are configured correctly in your directory settings to allow for this notification. Finally, verify workspace creation by checking the Workspaces section to confirm that the instances have been created successfully for each new user. Finally, let's ensure multi-region resilience for our workspaces. First, set up user directories in both regions. Create workspaces in the primary region and standby workspaces in the secondary region. Enable data replication between the regions. Configure DNS for failover using Amazon Route 53. Test the failover process to make sure everything works smoothly. Conduct regular maintenance and testing to ensure ongoing resilience. And that's how you ensure multi-region resilience for your Amazon workspaces. Now let's set up IAM roles. First, log into the AWS Management Console. Navigate to IAM from the Services menu. Click on Roles in the left sidebar, and then click on Create Role. Select the type of trusted entity. Choose AWS Service. For the use case, select EC2 or any other services needed. Next, click on Next Permissions. Here, you'll attach policies. For an administrator role, select the Administrator Access policy. For a help desk team role, create a custom policy with super user permissions. For IT skills ministry students, create a custom policy for desktop access. And for Internet Cafe guests, create a custom policy for temporary desktop access. After that, click Next Tags, then Next Review. Name the role something descriptive like admin role, help desk role, IT skills role, or guest role. Finally, click Create Role, and there you have it. Your IAM roles are now set up and ready to use. Next, we will create IAM policies for the roles. First, for the help desk team, we will create a policy for super user access and name it Help Desk Super User Policy. Then, for the IT skills ministry students, we will create a policy for desktop access and name it Desktop Access Policy. Lastly, for the Internet Cafe guests, we will create a policy for temporary access and name it Temporary Desktop Access Policy. Now let's create user groups. In the IAM dashboard, click on User Groups in the left sidebar. Then, click on Create Group. For the group name, enter administrators and attach the administrator access policy. Click Create Group. Repeat the process to create groups for help desk teams, IT skills, ministry students, and internet cafe guests, attaching the respective policies. Finally, let's create users. In the IAM dashboard, click on Users in the left sidebar, then click on Add User. For the username, enter admin_test_user and select Programmatic Access and/or AWS Management Console Access. Click Next Permissions. Add the user to the administrators group. Click Next. Tags, then Next Review. Finally, click Create User. Repeat the process to create users for help desk teams, IT skills, ministry students, and internet cafe guests. By following these steps, you will successfully set up a comprehensive AWS environment for the Internet Cafe project. Thank you for watching, and we look forward to seeing you at the cafe.